When factoring polynomials, the first thing you always look for is the greatest common factor. If it exists, you extract that from the polynomial. Now, if your polynomial has 4 terms, you can use the technique factoring by grouping, where you extract 3 rounds of greatest common factors. But what if your polynomial only has 2 terms? In that case, it may fit one of our special factoring formulas. So in this video, we're going to look at the difference of 2 squares, difference of 2 cubes, and sum of 2 cubes. These are formulas that you'll need to be very familiar with and memorize. If the polynomial only has 2 terms, check to see if it fits one of the special factoring patterns below. The first pattern is what we call the difference of 2 squares. It looks like a squared minus b squared. So how am I going to recognize it? It simply means that the first term is a perfect square, the second term is a perfect square, and I see a minus in between. Hence, we have the difference of 2 squares. In that case, it's always going to have the same pattern for factoring. We would factor it as a plus b times a minus b. And by the way, those 2 factors are what we call conjugates. That is, they are the same 2 terms with a different sign in between. One's a plus, one's a minus. The next special factoring pattern for 2 terms is what we call the difference of 2 cubes. So the way we recognize this one is that the first term is a perfect cube and the last term is a perfect cube, and there's a minus in between. Now, the factorization of this one is a little more complicated than the difference of 2 squares. Notice it factors into the product of a binomial times a trinomial. So to learn this pattern, the first thing we're going to do is look at the signs. Now, if the sign in between my 2 cubes is a minus, then the first sign that I'm going to use in my binomial here is going to be the same sign. Okay, so if there's a minus between my 2 cubes, my first binomial factor is going to have the same sign. Then the next sign, part of my trinomial here, is going to be the opposite of the first sign that I use. So that one's going to be the opposite sign. And then my last sign here is always positive. So you can remember the word SOAP to at least get the signs right. Now, let's talk about how to generate the terms in each of those factors. So again, our first factor here is a binomial. Notice that a is simply the cube root of my first term, and b is the cube root of my second term. Once I figure out those 2 terms in the binomial, I'm going to use those to generate the terms in our trinomial factor. So whatever I got right here, I'm going to square to get this first term. Remember, we already figured out the sign is positive here. Now, to get this term, I'm going to multiply the first and last terms from my binomial together to get AB. And finally, to get this term, I'm going to square whatever I got right there. Okay, the good news about the next formula is that it's very similar. We'll go over that again. But we're going to change the signs. So the next one, we're looking at the sum of 2 cubes. So I have a perfect cube for my first term, a perfect cube for my second term, and this time a plus in between. The SOAP method works here as well. So whatever sign I have here between my 2 cubes, I'm going to keep the same sign in between the terms of my binomial factor. I'm going to choose the opposite sign for this position, and remember that last one is always positive. Okay, if it was a little confusing on the last round, let me repeat how to generate the terms of our factors in this formula, and maybe it'll sink in a little better. So next, what I want to do is figure out the terms of my binomial factor. So to get this one, notice it's just the cube root of this one. To get the second term of the binomial factor, it's just the cube root of this one. Okay, once I have those two terms, I'm going to use them to generate the terms of the trinomial. So to get this first term of my trinomial, I'm just squaring this term. To get the middle term of my trinomial, look, I'm just multiplying the first and last ones together, AB. And then to get my last term, I'm going to square this one. Okay, so square, multiply, and square. Now, when you get this factored, you may have the tendency to want to factor that second trinomial, but it's prime, so that's as far as we can factor it. Now, you may have noticed there's one pattern missing here, and that is the sum of two squares. The sum of two squares, that is, this one's a perfect square and this one's a perfect square and there's a plus in between, actually doesn't factor with real numbers. We say it is a prime polynomial. It can't be broken down into factors with real numbers. So let's apply these special factoring formulas to factor the following polynomials. Example A, we have 4x squared minus 25. Now the first thing I notice about that is that there's only two terms. It's different from the examples that we looked at in factoring the GCF. It's different than the examples we looked at with factoring by grouping, which had four terms. So the little two-term polynomials catch our attention. If it only has two terms, we want to know, does it fit one of these patterns? So notice our first term there, 4x squared, is a perfect square. 25, the second term, is also a perfect square, and I have a minus in between. So this is the difference of two squares. So I'm going to follow the pattern a plus b, a minus b. Okay, so what does that look like? We're going to have two factors multiplied by each other. The first term in each of those binomial factors is going to be the square root of the first term in our binomial. So clearly that is 2x. So I'm going to have a 2x in the first two spots. In factoring the difference of two squares, one factor is a positive, one factor is a negative. In the next two spots, we're going to choose the square root of this number. The square root of 25 is 5. So we have 2x plus 5 and 2x minus 5. That's the factorization of the difference of two squares. But remember, don't stop there. Build the discipline of checking your work. That can save you lots of mistakes, especially on a test. So to make sure that we factored it correctly, I'm going to go ahead and FOIL it out. 2x times 2x is 4x squared. The outside terms have a product of minus 10x. Inside terms have a product of plus 10x. And the last terms have a product of minus 25. Notice our two middle terms have opposite signs, so they cancel, and we end up with 4x squared minus 25, our original binomial. When you FOIL out conjugates, this always happens. Your outside and inside terms cancel, and that's how you end up with a polynomial just with two terms. All right, let's look at example B. We have 8x cubed minus 27. Again, I notice there's only two terms. The first term is a perfect cube. The last term is a perfect cube. And notice we have a minus in between. So we have the difference of two cubes. So we need to follow our special factoring formula. This means we're going to have a binomial factor times a longer trinomial factor. To get the first term in our binomial factor, we're going to take the cube root of 8x cubed. That would be 2x. Remember, the sign in our binomial is going to match the sign in our original polynomial. So we're going to have a minus right there. Then the second term in this binomial factor is the cube root of 27, which would be 3. Again, because 3 times 3 times 3 gives me 27. Okay, now I'm really going to be eyeballing these two terms as I generate the trinomial factor. So to get the first term in my trinomial factor, I'm going to square this guy right here. 2x times 2x gives me 4x squared. Okay, now remember, this is the same sign, so the sign I choose here has to be opposite. That's going to be plus. To get my middle term, I'm going to multiply the first one and the last one. 2x times 3 gives me 6x. And then remember, my last sign is always positive, so this is going to be a plus. And then finally, to get this term right here, we're going to square the 3. 3 squared gives us 9. So that is our factorization. Okay, let's check it for good measure. Remember, when we're multiplying a binomial times a trinomial, we're first going to distribute our first term, 2x. So 2x is going to get distributed to all three of those. Let's see what that gives us. 2x times 4x squared gives us 8x cubed. 2x times 6x gives us 12x squared. 2x times 9 gives us 18x. To finish our multiplication, now we'll distribute our second term throughout the trinomial. Negative 3 times 4x squared is negative 12x squared. Negative 3 times 6x gives us negative 18x, and negative 3 times 9 is negative 27. Okay, let's combine like terms. So we have 8x cubed for our highest powered term. Notice we have a positive 12x squared and a negative 12x squared that cancel. We have positive 18x and negative 18x that cancel, and we end up with negative 27. That matches our original binomial exactly. So we can be confident that we have it factored correctly. The next example will be similar. Notice the first term is a perfect cube. The last term is not only a perfect square, but it is also a perfect cube. And we have a plus in between. So here's an example of factoring the sum of two cubes. So we got to follow our special pattern. So remember, when we have the sum of two cubes, the factorization will include a 2-term binomial and a 3-term trinomial. Now, to get the first term in our binomial factor, I'm going to find the cube root of 64x cubed. And that would be 4x. 4x times 4x times 4x gives me 64x cubed. The sign in my binomial is going to be the same as the sign in the original polynomial, which is a plus. And then the second term in our binomial is the cube root of our second term, 1, which is 1. So we have binomial factor 4x plus 1. To get the first term of our trinomial, we're going to square this guy. That's going to give me a 16x squared. I'm going to have an opposite sign here. To get my middle term, I multiply first and last. 4x times 1 gives me 4x. Last sign is always positive, and I'm going to square this term. 1 squared is 1. So that is our proposed factorization. I say proposed because I want to be absolutely sure. So let's check with multiplication. So I'm going to check by distributing first the 4x to all three terms. 4x times 16x squared gives me 64x cubed. 4x times negative 4x is negative 16x squared, and 4x times 1 is 4x. Then we'll distribute our 1. That should be pretty easy. We're going to get 16x squared minus 4x plus 1. And picking up our like terms, noticing our opposite signs there, we end up with our original 64x cubed plus 1. I hope you build the discipline of actually checking your work. It'll do two things. First, it'll make you practice both factoring and multiplication together. Second, it'll allow you to catch your own mistakes. And maybe even third, help you to build your confidence in your skills. Okay, one more example for this video. We have 64x squared plus 1. 64 is a perfect cube, but it is also a perfect square. So my first term is a perfect square. The second term is a perfect square, but there's a plus in between. So don't let this one fool you. Remember, the sum of two squares is not factorable. So that's kind of good news. If you're tired here, this one's prime, and we are done with that one. So please take some time to memorize and practice these special factoring formulas.